working in a project with development mode, working in a project in a kind of feature maintainability mode. Feature maintainability in the sense that kind of enhancement or bug fixing is software is available. Whereas in development, software is not available. Means someone is developing the software from the scratch. So in development mode, a developer need to include many libraries. Where in maintainability code, the developer has the software. So in both cases, a developer needs to know about the either library package or the current software. If we see Python is kind of loosely or it doesn't have any explicit type, function signature, class attributes, module attributes, wherever you see. The variable they do not have type means Python understands and it instantiates the typing implicitly. Programmer can explicitly declare a variable but not required. Means there are kind of notations through which, like if it is double quote then it is a string. Otherwise if it is kind of a decimal number then it is an integer or it is a float. So problem is, so if I am developing a software or I am kind of maintaining a software, how I should proceed? That is a big task. One work is that I can go ahead and I can just look at the library package if I am developing, or if I am maintaining the current software packages and source code and class code. It's a multi 10,000 lines of code that I need to understand before I start. It takes months. Like any widget programming, if I need to use a widget, then I'll go with the widget class, then search here and there all the derived classes, then think about its kind of usability, means which widget I should use. In Python, adding to a class data structure or adding an attribute to the class instance is runtime. You can add in any methods, in any function. You can kind of grow your class data structure, class instance data structure. Reading code is kind of cumbersome. So what is the solution? Solution is that I should know the design of the library package or design of the current package in advance. If I have the design package, means kind of package diagram or class diagram, interclass diagram, interpackage diagram. So these are called kind of UML schematic diagram or kind of architectural diagram. So rather than going inside the code and picking here and there, it's very nice that if I start my work, rather than investing weeks or months in understanding code here and there, we can have a kind of architecture in the hand. I can take printout of the architecture. I can just browse on my mobile. So if I need a particular class to be used, just I can browse the class diagram, interclass diagram. Inside the class, if I narrow down in few classes, I can just browse through the attributes and its methods, and I can decide, okay, so at this place, this class, I need to instantiate. So class diagram, package diagram, I need to have in my hand. So how I can proceed? I am writing a code, library package or the current software architecture, how I can do it? I have Python source code. Python source code is not a big deal. Means if I install a software in Python, Python source codes are available. I mean, they only execute. Or if software includes a shared library, then Python code means for famous library, anyway it is available on GIT Hub, code repository or something. So getting a source code in Python is not a kind of a big issue. So if I have a Python source code, a solution is there any tool or software that would kind of parse the Python code and give me the architecture? I did not go all the places and see that if someone is attached to self or someone is attached to the class data structure or something like that. It's not C++, where the initialization generally happens in the constructor or something. Anywhere kind of attribute initialization or attribute addition can happen. So if I get to have the architecture of the class of the library package or the current package, it is a kind of a boom. Means you can start immediately if you have the blueprint of the architecture. So we'll see the pyreverse tool that parses the Python code and then it generates the kind of the architectural blueprint, package diagram, class diagram, inter-class relationship, everything is there. There are few things that is lacking in pyreverse. Like for in a class diagram, we don't have the derived classes, only the kind of parent classes are there. Kind of, we can have our own software that uses the pyreverse, and whatever is lacking, that you can fill in. Just run the tool in 1 hour, 2 hours, full architecture is there. Just use the architecture kind of in PDF format or something. You can just, when you are free, you can just sit and browse the architecture. Start using it. So we'll see that how in a reverse engineer we can generate the UML architecture, class diagram, package diagram, and interrelationship through pyreverse and any tool that is using the pyreverse. That is.
Further to a discussion on generating the UML diagram through reverse engineering in Python code. So we'll see AMP, atomistic machine learning package. This is Linux Mint. Okay, so as discussed, discussion is about how to generate reverse engineering code that is kind of that gives a good idea about the design of the package. Okay, so we are talking about AMP, atomistic machine learning package, that is used in kind of chemistry, where kind of property of molecules and material, so that need to be known through its structure. So there is a kind of atomic neural network. Okay, so it predicts the property or energy, surface energy kind of. So it is used in chemistry area. Okay, so pyreverse is the tool that we are using now to generate the reverse engineering UML diagram, class diagram, package diagram. In class diagram, inter-class relationship, and in package diagram, inter-package relationship. Module also comes under package. Okay, it uses modeling element like generalize, containment, aggregation, composition, dependency, and association. Okay, so association is a relationship which is not dependency. Like a student is kind of associated with many research organization. Okay. Dependency means kind of one class calls another class, one function calls another function. So it is dependent upon it. Generalize is inheritance or interface realization. Aggregation is part whole life relationship. Composition is whole life relationship. Okay. So kind of if class it is getting destroyed, then all its composition would also get destroyed. So that is composition. Aggregation means if class get destroyed, then its composed aggregated objects would not get destroyed. So this is typically if object is passed as an argument. Okay, so AMP package is kind of so pyreverse can be installed through package manager or PIP. Package name is pylint. AMP can be installed through package manager. AMP kind of its code base can be downloaded from GitHub. We can check the version of AMP and other packages. pyreverse -h help can be kind of printed, and it is mainly module list or package directory that need to be specified. -capital A is all ancestors, all associations, module format, complete module format, kind of a top module to the last module in dot dot, or only module name, last module name. -k only class name. -c for any particular class, all properties and its attribute. -a is for how many levels of inheritance we want, that is small a is how many level of association, -m module, -k, -c. Okay, we need to must set the Python path of the package directory. Okay, so that's it. So we will install. Okay, so it can be installed through package manager, sudo apt-get install pylint. It is installed. We'll install GraphViz also, that is required for kind of PDF generation and those. Okay, it is installed. And Python 3 AMP, it is also installed. Okay, what are the versions that quickly we can check? dpkg -l, egrep -e, pylint, GraphViz, and Python 3 AMP. So this is what we are using. These are the versions. Okay, so if I see dpkg L Python 3 AMP. So AMP is installed in dist packages. So this is the installation package, a directory, and AMP is the package that we want. Okay, that's it. Now we'll start using it. So pyreverse -h. Okay, filter, what filter we want, kind of public only or all attributes. So right now it is pub only. Class -c class name, -a ancestor, capital A, small s, capital S, Okay, hyphen B is for show built-ins, minus M, yes and no, minus K, okay, hyphen O, colorize, if you want colorized output, kind of each level in colorization would be different, maximum level of depth in colorization, how many level colors we want. Ignore particular file, set a project name this for this output, and minus hyphen D where the output of the where the UML diagram would go. Okay, so we'll create a directory pyreverse amp. It's empty directory. Okay, so as per the what we talked, so we'll draw kind of first package diagram. So we'll see a little bit kind of introduction about the package diagram. Okay, so kind of package diagram is nothing but directories which contain the module can be behaved as a package. It has underscore init Python code where full-fledged Python code can be written. Like base is the directory. Inside that package1, package2 subdirectories are available. And then mode 1 and mode 2 modules are available. So mode 1 is in package 1 and mode 2 is in package 2. So if this is the code, then it would draw this package diagram. Okay, so this is kind of a base package and it is depend upon package 1, package 2, depend upon package 1, depend upon package 1, package 2, module 2, whereas like this, the way it is. This code would generate this class diagram. There are three classes in module 1, package 1, module 1, class A is there, package 1, package 2, module 2, class B derives from it, whereas in package 1, module 1, B class is also derives from it. So, if directory structure is like base contains package 1 and package 1, 2, package 1 contains package 1, 2 and they contains modules, then it should draw. Okay, so directory structure is like this, like a package contains sub-package and a sub-package contains sub-package. A sub-package may contain again sub-package. It's a kind of recursive. A sub-package may contain module. A sub-package may contain only module. Okay, so we'll see at each level, package level, sub-package level, module level and class level. So module can contain class, module, sub-package, package. Okay. Okay, so little introduction about AMP. It is atomistic machine learning package, like in atomic, in chemistry, in kind of where the idea is like if molecular structure is there, any material structure is there, it would belong. So what would be its property or how much energy it contains? So there is a neural network in between that is kind of trained, charged, and its kind of its matrix weights are already filled up and with some kind of training data. And if molecular structure is given in a kind of binary format, then through input layer and hidden layer, and then it outputs the property. So this is the atomistic machine learning package. Okay, so we'll see the packages, sub-packages, and then we'll start. So it is installed at user local user lib dist python 3 dist packages amp. And these are so AMP is the top level package. The way we see the AMP is the top level package. And inside that there are sub packages like descriptor, regression, model, and inside model there is no sub packages, whereas modules are there, neural network and deep flow. So this is AMP, this is model, and inside model there is a module called neural network. Inside module there are classes. We can find the classes. So we can say kind of find. Okay, so E grep minus E class, and that is inside the model. There are three classes: neural network and revealer and node plot. So neural network derives from model. Okay, so there would be a class called model somewhere. Okay, so that is the scenario. Now we'll proceed the way it is. So we can say pyreverse. My user lib python 3 dist packages AMP minus ASMY. So complete. We'll see if it passes through. It may be big. We'll ignore tests. Okay, and output format would be PDF. Now full package diagram it is drawing. Okay, so we'll cancel this. It is taking too much time. And we'll try with minus a single level of association -m. It has to pass through because single level of association is not very big. And number of sub packages and module is also small, so it should pass through. It is done. So we have package diagram first. Okay, so neatly drawn package diagram. So if we see, then we are at AMP. AMP depend upon the Gaussian utilities, and AMP model utilities, analysis, regression utilities, descriptor cutoff. So means full package interrelationship diagram is there. This is amazing, so nice. Okay, so let's see class diagram. So these are the classes that we can see. So full properties and attributes are listed. If we want not colorized, so this is kind of full architecture of the package. How it is calculated, package diagram especially, then we have to open the code. Python 3 dist package AMP, and we have to see imports. Import ASC from ASC calculator. Okay, so these are the kind of packages AMP depend upon. Okay, import ASE from ASE calculators, from utilities. Okay, so utilities, and there would be descriptor also. So utilities and descriptor, mainly it is depend upon. So there would be descriptors also. Okay, so from descriptor dot Gaussian import, so it is depend upon dot descriptor Gaussian. So it parses full file and then creates so neatly the package diagram. Okay, now we can create kind of colorized output. So whatever we did, Python 3 pyreverse and minus AS1 minus my and user lib Python 3 dist packages AMP ignore test OPDF colorized show built-in. Okay, so I believe it should be over. Done. Now we can see package diagram. It is colored. Level of color. AMP is dependent upon Gaussian and utilities. And like this. So different level, different color. Same in classes. Okay. So we printed built-ins also. So this is along with built-in. This is a kind of one PCB design. Means it is too complex, but this is how it is. Or if we don't want this much, we can just say kind of don't show me built-in, colorize is okay, minus k, hyphen k, only class name. Okay, so we'll browse the classes.pdf. Only class names, no class properties and methods, and this much we get, like ASE calculators calculator. So this much we get in package. So this is complete package diagram that we get. Okay, like that we can see the sub packages. So we'll see sub packages like AMP model, ignore test, we will remove colorized, and complete class diagram. So we'll see packages first. Okay, it is taking unusual more time. Okay, finally it is done. So these are the packages. Okay, so kind of independent packages. Class diagram, nice class diagram it generates at sub package level. Okay, this is what it is, means properties and everything together it shows. So there are classes like neural network in model. I believe it is too much. So we'll generate with minus k. It should finish quickly. So we'll see classes dot pdf. So nice it is. Means neural network derives from model and it contains these classes, revealer, regressor, okay, and kind of loss function. And loss function again contains calculator parameters. Okay, it contains logger, and logger is contained by neural network also. Neural network, T-flow neural network or neural network dot neural network, they also contain logger. Yes, it is. You can, someone can understand the architecture of model sub package. Yes, it is really nice. Okay. Matplotlib backend and PDF pages and noteplot. These are independent classes. Now we'll come to module level and class level. So same thing we can do for module. So here we have neural network. Okay, so if I do ls user lib python 3 dist packages amp and model. Okay, neural network is a module here, so I can say neural network and all classes in that. I can go for all associations. Let's try. Okay, I shall remove rm everything. There is nothing now. Minus c is not required. It should succeed because it's a single file. So minus asmy should succeed. And let's see what it generates. Okay, it is taking time. We expect if it is take more than 10 seconds, we'll kind of interrupt it. And looks like there are too many associations and it is taking too much time. Okay, so it is taking too much time. Not this much is not expected. So what we can do is we'll try with a single level of association. One. I believe it should kind of pass through. This is how we have to use pyreverse. It has to pass through because it has already passed through. It passed through. Now we have classes. Okay, so this is all class diagram and its relationship in a particular module. So this is how it is. Okay. Now we can go for kind of single class also at this level, class level, down the line. Okay, so we'll say ignore test PDF. Okay, I'll remove everything first. And class is neural network. I hope it should work. Now we are printing only for a particular class, not at module level. There is no class. Neural network. Oh, so this is the class diagram of neural network. If someone is happy, it's very nice. All classes, it prints the methods and properties. We can go for -k, -k, kind of just for the its architecture, not the method and property. Okay, so this is what we wanted, neural network model. Okay, so this is all about pyreverse. Now we have pretty print of the module and package and classes and everything. So kind of this is a wrapper over pyreverse that we have written. Python 3. Okay. It kind of there are few limitations in pyreverse. One is Python code, it doesn't work. If there is Python code, it won't work. And class diagram also, either it will print all the properties, that's what we saw. It will print properties and method of all classes, or it will just show the only skeleton, only the class name. Okay, so this kind of is better. Like everything is there. If we want to, for neural network also I have to see. So diagram becomes very big, unnecessary. It doesn't fix Python codes. If there is a pyx file, pxd file, pxi file, or Python interface file, pyy. So this tool does everything. So we can run this tool like Python pyreverse.py fix user lib python 3 dist package and amp. Okay, it fixed. Now if it has a Python code and a whatsoever, it fixed everything, and it generates amp directory. Inside that all fixed code is there. Now I can say Python 3 pyreverse minus modify, and then I can specify which one. So I can say for complete ASM. Okay, now I have to specify a class name, highlighting. So I can say model dot neural. Okay, I don't remember the name. Model AMP model neural network. So it will be Python 3 pyreverse modify ASM AMP dot model dot neural network dot neural. So this is the class we want. Okay, so there is some error. So we have to specify nicely pyreverse. In this package name is wrong, AMP, and inside AMP we want model.neural network looks better. Okay, it times out if it is means no need to worry about timeout, and someone need to specify S1 or something like that. One thing. Second thing is it prints everything like built-in variable and colorized, and just type it, and okay, so it times out. So it will try with minus S1. It mentions it is trying with minus S1. It may take a few seconds only, the way it had happened. Okay, so now it generated kind of a neural network dot PDF and like this. So I can see AMP model. Okay, so this is how the package diagram. So same package diagram it generated, but only a skeleton, not all the properties, and it is all the built-ins is also there. I think if we remember the built, including built-in, it was like kind of too many. Okay, so that it avoids. And it highlights a neural network. This is what we are saying. Okay, so it highlights a neural network. For neural network, properties and its methods and its properties are highlighted. Otherwise, complete skeleton means just we can assess the diagram, the design, how it is. Okay. Okay, so next thing is it kind of draws for all classes. So I can remove dot PDF and I can fire for all classes. Just AMP, then it will go for all classes. If I say AMP model, so this is for this file, I can say ignore test. So it found 3 classes, and in 3 classes it will generate kind of one clubbed PDF file. Okay, so if it times out, then it will try with minus S1 option. This is what it is doing. So in one go, we can generate a class diagram for all classes in a particular module or package or something like that. Okay, so second class it is trying. It may also time out. So we are drawing a kind of module diagram, but in module each classes it would do class by class. Okay, it times out again. So nothing to worry, means it does everything. Okay, so third class it is trying, probably it would time out too. Okay, so it creates a directory called output. Inside that, this is the kind of a clubbed uh, architecture of neural network module. Okay, so we have to say events. Okay, so all three classes in a particular module it draws like so nicely. Like neural network derives from model, and then it has these containments, and neural network node plot. If containment is more, that we can see, if containment is more, rather than kind of too many boxes, it clubbed together in one box, that in yellow color, that we can see. Okay, so this is a class diagram inside a module, so nicely it draws. Okay, so we can go for full package diagram, all classes in the package. So I can say for all classes, it would take some time. Now full AMP generate the class diagram. Now 31 classes are there, 3 classes are done. So I believe 34 classes total. I don't know how long it would take. Now parsing all modules, all packages, sub packages, its init file, and then it is drawing the class diagram. It will fix the kind of derivation. So it will print a parent class, base class, derived class, everything. Okay, so it would take time. Okay, so it is done. It took some time though. Okay, so we'll see the clubbed file and how it is. So this is all classes it is doing. If there is a derived class of a particular class, it prints in green color. Everything means kind of a full package for each class. Okay, if too many associations are there, too many kind of containment, then in yellow package clubbed together. All built-ins, built-in dict, built-in exception, base exception. So nightly it printing node plot, neural network. Okay, AMP model, so is a base class for neural network. Loss function, everything. Okay, so we covered all points. In lab session we covered package, sub-package, module, classes, and here we covered how to do. Okay, Python path we did not set because it is kind of already in the Python path. So if I print Python 3 C import sys print sys.path. Okay, this is already in Python path, so not required. And when we ran the kind of custom py reverse, so there AMP directories, AMP directory is already available. AMP directory already available. So Python path is not required because anyway it is at package level. Okay, so nice diagrams. It is generating per class wise.
Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.